Awesome. So today we're going to be talking about power and electric circuits, and which is literally so cool because it's all around this room, it's all around our lives, it's in almost everything we do. We see electric circuits everywhere. They're very, very now integral part of our lives, and yet we never recognize them, or we seldom see them around us. And it's really cool to see that 200 years ago was kind of the first electric circuit that was ever created by Alessandro Volta. And he did it with just a bucket of salt water and some metal strips, and that had like a little bit of an electric circuit. And now, obviously, it's like so much different, so much more complex, so much more unique, and yet it's also still so similar. It's still like on similar principles, and they're really the same principles. And so, hopefully, by the end of today, we can understand what this is, what power is. We all have, flipped on a light switch before. I'm sure a lot of us have blown a light bulb before. But it's kind of like if you the more powerful a light bulb is, like the brighter it's going to be. The more power it receives, the brighter it's going to be. And power is measured in watts. Okay. And we're just going to go through the units and some formulas real quick so you can kind of grasp a mathematical understanding of what this is. And watts is basically joules per second. And joules is just energy. Right? We think of joules as just energy. Okay. And so really what we're measuring with power is how much energy there is over a certain amount of time in a circuit. Or in other words, we can say it's the amount of work done over time is power. And when we think of it this way, we can also look at a couple other equations, especially in electrical circuits, right? And we have this wonderful equation: potential energy is equal to QV, right? Where Q is a charge and V is voltage. And when we do this, work over time, we can do PE over T is equal to QV over T. Okay, and this is equal to power, which we have the V right here. Right, we have our voltage, and this your charge over time is actually something called current. And I love this. Helps me understand what current is so much more, right? We talk about it as it's a flow. It's like the flow of electricity moving through a circuit in a given amount of time. It's a charge moving through a given amount of time. And this equation is the one equation for power that is always constant. No matter what the circumstance is, we can always use this equation, where it's directly linked to current and voltage. We also have two other equations, where P is equal to V squared over R, and where power is equal to I squared R. Okay? And this is the thing about these two equations for power is that it's only going to be used when we have a resistor present in the circuit. If there's no resistor, then you can't use that because there's no resistance. And with this top one, you can see if we just increase the voltage a little bit, and if there's a resistor in a circuit, and we increase the voltage a little bit, like by a factor of 2, then your entire power will be increased by a factor of 4. So if we had 2V squared equals 4P. Whereas this one, if you did it for current, it would be the same thing, right? If you multiply the current by 2, so if you had 2I squared, then you'd have 4P. And if you did resistance by 2, then you just have 2P. But ultimately, like the units are all the same, the principle is still the same, and it's still just, you're still just measuring energy over time. So let's do like just a really quick demonstration. All right, so we have this circuit. Okay, and we'll say it's like a 12 volt battery. Okay, and we'll say that the current is 10 amps. Okay, and remember, amps is just charge over time. Okay, so we have 12, we have P is equal to IV, then we have P is equal to 10 amps times 12 volts. All right, and that's going to equal to 120 joules per second, or in other words, 120 watts. Okay, so that'll work for any electric circuit. Now, if we throw a resistor in there, let's try another one real quick. Okay. If we throw in a resistor right here, and let's say we have a 10 volt battery, then we have to use one of the, we should probably use one of those other two equations. And we're given that there's 30 ohms of resistance. Okay, so then we come over here, right? Which one do we have? We don't have current, but we do have voltage and resistance. So we can do P is equal to V squared over R. And so we do, which is equal to 10 volts squared over 30 ohms, which then would be 100 over 30 joules per second, or in other words, 100 over 30 watts. And there you go. So it's pretty simple, but this is kind of how we calculate and how we use watts. And if we were to compare these two, right, 100 over 30 versus 120 watts. If we compare these two circuits together, then which one is going to have more power? Which one is going to have a brighter bulb? If we were to have a light bulb in it, the 120 watt bulb is going to be brighter. And so yeah, there you go. It's pretty simple. You can take it or leave it, but I like it a lot. So there you go.